Welcome to Learning Fun Zone, where learning is always a blast. Today welcome to stepping into an exciting new world, the binary world. Imagine a language that only uses two symbols, 0 and 1. That's what computers use to talk, to think, to play games, and to show us videos. It's a unique way of representing information using just two options. Sounds intriguing, right? So buckle up, folks. Get ready for a fantastic journey into the world of binary code. So you might ask, what is this binary code? Well, let's unpack that together. Binary code, in its simplest definition, is a system that computers use to represent all sorts of data. This could be numbers, letters, or even your favorite cat video. Now, what makes binary code interesting is that it only uses two numbers, 0 and 1. Imagine if you could talk to your computer using only two words. Sounds challenging, right? But computers do it all the time, and they're really good at it. In binary language, each of these zeros and ones is known as a bit, which is short for binary digit. Now, you might be wondering how we can express so much information with just two numbers. The magic lies in the combination of these bits. Similar to how we combine letters to form words and sentences, computers combine these bits in different ways to represent different pieces of information. So, when your computer is processing a picture, playing a song, or even when you're just typing an email, it's all happening in this secret language of zeros and ones. Every letter you type, every pixel in your picture, every note in your song is being translated into this binary code for the computer to understand and process. Now that you know what binary code is, let's dive deeper and see how it works. In the next scene, we'll unravel the magic of zeros and ones. So stick around, there's a lot more to learn. Imagine being able to talk using only two numbers, 0 and 1. Sounds fun, right? Now let's delve into the magic of these two simple digits. They might seem ordinary, but when it comes to computers, they're as magical as a rabbit being pulled out of a hat. The binary system, also known as the base 2 system, uses only 0s and 1s to represent all possible numbers. You see, while we humans count in tens, computers count in twos. This is because computers use electrical signals, which can be either on or off, hence the two states, 0 and 1. Let's take a ride on this binary roller coaster, shall we? Imagine a world where 2 is written as 10 or 10 in binary. No, I haven't lost my marbles. That's just how it works in the binary system. And if you think that's fun, hold on to your hats, because 7 is not 7 but 111 or 111 in binary. Just think about it. Any number, no matter how large or small, can be represented using only 0s and 1s. Consider the number 25. It's 11001 or 11001 in binary. Now that's a mouthful, but don't let that intimidate you. It's just like learning a new language. At first, it might seem strange and unfamiliar, but with practice, it becomes second nature. You start seeing patterns and connections, and before you know it, you're speaking fluent binary. And it's not just about numbers, oh no. Letters, symbols, images, sounds, and even videos can all be represented using this magical combination of 0s and 1s. That's right. The video you're watching right now, the music you're hearing, it's all just a bunch of 0s and 1s to a computer. Isn't it amazing how you can represent any number using just 0s and 1s? The world of binary is a world of endless possibilities and mind-boggling magic. So the next time you see a 0 or a 1, remember, there's more to them than meets the eye. Now, what if I tell you that not only numbers, but even letters can be represented in binary? Yes, you heard it right. Just like numbers, each and every letter of the alphabet has its own unique binary code. Let's start with the basics. In the realm of computers, the English alphabet is usually represented through a standard known as the American Standard Code for Information Interchange, or ASCII for short. This system assigns a unique binary sequence to each letter. For instance, the uppercase A is represented as 01000001 in binary. Interesting, right? So how does this work for all the other letters? Well, similarly, each letter, whether it's an uppercase or a lowercase, has its own distinct binary code. For example, the binary representation of the uppercase B differs from that of the lowercase b. This allows computers to differentiate between them just like we do. Now you might be wondering, what about punctuation marks and symbols? Do they have binary codes too? Absolutely. In fact, every character that you can type on a computer keyboard, including numbers, letters, punctuation marks, and special symbols, has a unique binary code. Imagine this. You could write a whole story in binary code. It might look like a long string of ones and zeros to most people, but to a computer, it would be a captivating tale. You could even write secret messages to your friends in binary code, and only those who understand binary would be able to decode it. You might just become the best secret messaging agent in your friend circle. So there you have it. The power of binary code extends beyond just numbers. It encapsulates letters, symbols, and even your favorite emojis. Isn't that incredible? With binary code, you can write your name, a message, or anything you want, and only you and the computers will understand it. Before we wrap up, remember that understanding binary can be as easy as 1, 10, 11. Let's take a quick stroll down memory lane. Today, we explored the fascinating world of binary code, the secret language of our computers. We found out how this language, composed entirely of zeros and ones, forms the backbone of all digital communication. We also discovered how our alphabets can be represented in binary code, opening up a whole new world of secret messages we can write and decipher. I encourage all of you to try it out. Write your name, a secret message, or just a fun note in binary and decode it back. It's like having your own secret language. And here's a fun joke for you. Why don't computers like to go outside? Because they get too many bits. Don't forget to subscribe to Learning Fun Zone for more fun learning videos. See you next time.